Welcome to this explainer. Today, we're diving straight into that absolutely crucial, but let's be honest, often totally overlooked step that happens the second software development finishes. You know the drill in the system's lifecycle. Once a new system is fully developed and tested, you can't just toss it over the fence. We need the right instruction manuals and technical guides to actually make the thing useful.
So here's our roadmap for today. First up, the handoff problem. 2, the user dashboard. 3, the technical blueprint. 4, shared reality and divergent needs. 5, the documentation ecosystem. And 6, we'll wrap up with a quick knowledge check.
All right, Section 1, the handoff problem, or translating the fully tested system. Because handing over a shiny new system, it's never as simple as just flipping a switch.
Seriously, you cannot just hand raw code to an end user. It's a recipe for disaster. A fully developed, fully tested system has to be translated into 2 completely distinct paths. We're talking instructions for the experts going one way, and instructions for your everyday users going the exact opposite way. It's all about speaking the right language to the right person.
Think about it like a car. Everyday drivers really just need the dashboard, right? How to navigate, turn on the AC, actually drive the thing. That's your user documentation. But the mechanics? They need the heavy-duty engine blueprints to understand the core design logic so they can actually fix those complex internal structures. Because, well, you definitely don't want everyday drivers trying to rebuild a transmission in the company parking lot.
Moving on to Section 2, the user dashboard, guiding the end user experience. Let's look at how this builds into the specific needs of our everyday drivers. If we map out the typical user's journey, we see a super practical progression. Day 1 is all about getting started. They just need to know how to install and boot up the software. By days 2 and 3, they're leaning heavily on visual aids for basic core operations. Fast forward to day 7, and they're confidently managing records and handling data entry. And eventually, around day 30, when things inevitably go wrong, they're reaching for those troubleshooting guides and FAQs to get themselves back on track.
Okay, Section 3, the technical blueprint. Mapping the engine for experts. Time to look under the hood at those complex, behind-the-scenes details that programmers and systems analysts absolutely live for.
This is exactly what technicians need to repair, maintain, or upgrade the system. It's a really deep, analytical look at the internal structures. Completely unlike the user dashboard, this is strictly focused on the how and the why of the underlying design logic. Basically, technical documentation entirely skips over basic usage. Instead, it packs in 6 crucial components to explain how the software actually thinks. We're talking about the raw program code itself, plus the logic laid out in flowcharts and algorithms. Then you have strict system requirements for hardware and memory, alongside the data rules, like file structures and validation routines. Top it all off with a running list of known bugs and a full glossary of variables, and you've got a world that looks completely foreign to an everyday user. Which brings us to Section 4, Shared Reality and Divergent Needs, where the manuals overlap. We're at the intersection now, looking at exactly where the driver and the mechanic share a reality and where they firmly go their separate ways.
It's fascinating to see how clearly the boundaries are drawn here. Notice how things like hardware requirements, the overall purpose of the system, and error messages are totally vital to both groups. But the heavy lifting, like the actual program coding and validation rules, those remain completely isolated on the technical side. Meanwhile, basic stuff like how to load the software or FAQs, strictly for the user.
The reality is, while both groups absolutely need to know the ultimate purpose of the system just to do their jobs, an end user has zero reason to ever look at a validation rule. Keeping these worlds distinct is a game changer. It stops users from getting totally overwhelmed with code and keeps technicians from getting bogged down answering basic operational questions.
All right, Section 5, the documentation ecosystem, the continuous loop of maintenance. Let's dig into how these 2 distinct worlds actually trigger actions for one another.
Because, you see, these groups aren't operating in total isolation. When an end user hits a glitch on their operational dashboard, it sets off a whole chain reaction. That single user action crosses the divide, goes straight into the mechanic's engine room, and eventually results in a system patch that loops right back around to the user. Breaking down that exact cycle step by step, it usually starts with a frustrated user searching their FAQs. Once they realize it's a legitimate system error, IT gets notified. Then, the programmer steps in, cracking open the technical docs to check flowcharts and track down the flaw. After the code is patched, both sets of documentation have to be updated. So the user gets new visual aids or troubleshooting steps, and the technician gets an updated known issues list.
It's a living ecosystem.
Now, for Section 6, quick knowledge check. Navigating real-world scenarios. Let's take all of this and put it into practice with a few rapid-fire, real-world scenarios you might actually face on the job.
Think of this decision tree as your mental guide. When a crisis hits, or even just a minor hiccup, you need to know exactly which manual to reach for without hesitating.
Okay, scenario number 1. Imagine you're just doing your daily tasks, maybe you've got a line of customers waiting, and you completely draw a blank on how to add a new record to the system. Which manual do you grab?
You'd immediately go for the user documentation, right? Specifically, the section on managing records. Because adding or deleting customers is purely an operational dashboard level task. You really don't need to know how the database was built behind the scenes, you just need to know how to use it right then and there.
All right, let's flip it for the next scenario. What if you were the one tasked with hunting down a really stubborn bug that is completely breaking the software's logic? Well, that requires a deep dive straight into the technical documentation. You're going to need to check the core logic, study the program flowcharts, and comb through the actual code to figure out exactly why the software isn't behaving the way it's supposed to.
Finally, let's say the entire company is getting a massive hardware upgrade. Shiny new machines for everybody. Who holds the necessary specifications to guarantee the software will actually run on the new gear?
This is that overlap area we talked about. Both manuals actually list hardware requirements, so theoretically you could check either one initially. But if you're spearheading a massive system-wide upgrade, you're definitely going to want the technical guide. That's where you'll find the absolute nitty-gritty specifications and minimum memory requirements to ensure complete compatibility.
So we've seen exactly how the dashboard and the engine work together, but I want to leave you with a final thought to chew on. You can build the most beautiful, complex, and rigorously tested software in the world, but is that system truly durable if no one knows how to drive it or how to fix it when it breaks? The life cycle of software doesn't end with the final line of code. It survives entirely through the manuals we leave behind. So what kind of manual are you leaving behind? Thanks for tuning in to this explainer, and I'll catch you next time.